Hey everyone, Teacher Chang here, and today we're going to be using the Pythagorean Theorem to help us determine if a triangle is an acute, right, or obtuse triangle. We're also going to be using the Pythagorean Theorem to solve for missing variables in a right triangle. So let's go ahead and get started. We already know that the Pythagorean Theorem only works for right triangles, but we can also use this relationship to determine if a triangle is obtuse or acute. We already know that the Pythagorean Theorem is typically written in the format of a squared plus b squared is equal to c squared. And because of the reflexive property, we can go ahead and rewrite it so it says c squared is equal to a squared plus b squared. Now, because we have it written in this format, we can go ahead and replace that equal sign with a less than or a greater than sign. And if c squared is less than a squared plus b squared, then we can say that it is acute. It's going to be an acute triangle because that c squared is less than a squared plus b squared. So less means smaller, which means it's an acute triangle. Now, if c squared is greater than a squared plus b squared, well, greater means bigger, which means it's going to be an obtuse triangle. So if we have a relationship where our c squared is less than a squared plus b squared, we know we have an acute triangle. If c squared is greater than a squared plus b squared, well, that means we have an obtuse triangle. So let's go ahead and put that into action by identifying what type of a triangle we have here. So here we got three triangles, and we're going to take a look at these one at a time. Now, the most important thing that we need to do here is to identify what is our C value. That's always going to be the longest side. So in this first one on the left, we have a triangle with the measurements of 10, 24, and 26. Well, our C value is always going to be that longest side, which is going to be that 26 in this particular case, which means the A and the B are the other two sides. Now, it doesn't matter which ones are A and which ones are B. Typically, we write that A as the shorter side or the shorter leg and B as the longer leg, but again, it doesn't really matter. So I'm going to go ahead and write this relationship. So we have c squared is something. We're not sure if it's equal to, we are not sure if it's less than, and we're not sure if it's greater than that a squared plus b squared. So that's what we're going to try to figure out. So I'm going to plug in our c value, which is 26. So that means 26 squared. And anytime you substitute, you're supposed to put it in parentheses. And we're not sure what type of a sign we have in between. And then we have our a value, which is 10, and we're going to go ahead and square that one, plus our b value, which is 24, and we're going to square that one as well. So once we substitute everything in, all we got to do is the math. Well, 26 squared is going to give us 676. And, well, 10 squared is 100, and 24 squared is 576, and if we add those together, 100 plus 576, well, that's going to give us 676, which is the same thing that we had with our c squared. So that means these two are equal to each other, and because they're equal to each other, we now know that this is going to end up being a right triangle. So let's go ahead and try this next one over here on the right. Or in the middle. Let's take a look at the one in the middle first. So what we want to do is to figure out, well, which one's the longest side? Is it the 5 or is it the root 29? Well, we know it's going to be the root 29 because the square root of 25 is going to give us 5. And well, this is a little bit longer. So this is going to be our C value. Now, if you actually calculate the square root of 29, it turns out to be approximately 5.4. So we're going to leave it as root 29, and we're just going to plug it into our Pythagorean relation. So if I substitute that into our c squared and substitute the other two into our a squared plus b squared, well, we're going to check to see if that's going to be greater than, less than, or equal to our a squared plus b squared. So let's go ahead and substitute this in here. So we got our root 29, and what we want to do is we want to square that. Okay, so I'm just going to substitute here first. Now we're going to plug in our a and our b value, and again, it doesn't matter which ones are a and which ones are b. I'm going to go ahead and use 3 as our a value. I'm going to use 5 as our b value. And now we're just going to solve this. Now, the square root of 29 squared, that will cancel the square and the square root out, leaving us with 29. And then we have our 3 squared, which is 9. And we have our 5 squared, which is 25. Now, a lot of us may already know what this is going to end up being because, well, 9 plus 25 is going to give us 34. And well, if we compare that with 29, we can see that 29 is less than 34. And because it's less than 34, well, that means we're dealing with an acute triangle. Remember, less means smaller, which means it's going to be acute. All right, we got one more here on the right. And again, we want to identify that C value, and then that means we're looking for that longest side. So in this particular case, the C value is going to be our 22, while the other two will be our A and our B. So I'm going to let A be our 13. I'm going to let B be the 16. So again, we're going to substitute it into our relationship of C squared is either equal to, less than, or greater than our A squared plus B squared. And we'll plug everything in. So I'm going to plug in that 22. We'll put that squared with it. We'll put the question mark, and our A is 13. And our B is 16. So now we're going to do the math. Okay, 22 squared is 484. And then we have our 13 squared. 13 squared is 169. And 16 squared is 256. And if we add those two together, we're going to get 425. And now we're going to compare that with our 484, and we can see that our 484 is going to be greater than 425, which means we have an obtuse triangle. Okay, so this next problem that we have here is pretty much the same thing, except this time they did not draw the triangle. So what we're going to do is we're just going to take a look at the length of these sides. And again, we want to identify which ones are C value. Now again, the C value is going to be the longest side or the largest side. So in this particular case, the C value is this 15. So C is equal to 15. Now the other two, doesn't matter which one's A and which one's B. Again, I like to go ahead and use A as the shorter leg and B as the longer leg. So now I know what is A, what is B, and what is C. Again, we'll plug it into our Pythagorean relation. So C squared is either going to be equal to, greater than, or less than our A squared plus B squared. And that's going to tell us what is our triangle. So let's go ahead and plug everything in here. So we got our C being 15. So that's going to be 15 squared. We'll put in our question mark. And then A is going to be our 9. So that's 9 squared. Plus B, which is 12, so that's 12 squared. And we'll just go ahead and solve this out. So 15 squared is going to give us 225. 9 squared is going to give us 81. And 12 squared is 144. Now we'll combine the 81 and the 144, and that turns out to be 225. We compare that with our C squared, which is also 225, and therefore we can see that these two are equal. And since they are equal, we know we have a right triangle. So that's how you determine if we have an acute, an obtuse, or a right triangle. All you got to do is compare your C squared with your A squared plus B squared. So this next part is looking for our variable x. So here we got a right triangle. We see that we have a right triangle because of that right angle at the bottom right-hand corner. And we know from this right angle that we have a C value of 5. So now that means the other two sides are going to be our A and our B. And again, it doesn't matter which one is which. Let's just say that this bottom one is A. I could have made the other one as A. And this top one or this one to the right is B. Again, it doesn't matter which one's your A and which one's your B. So I'm not completely sure which one's the longer one, which one's the shorter one, because the triangles that are drawn are never drawn to scale. So I guess we'll find out in a little bit. Now, typically we write, since we know that this is a right triangle, we can write it as A squared plus B squared is equal to C squared. Okay, so I'm going to go ahead and substitute what we know here. So I'm going to go ahead and use that x minus 1 as our A value, and I'm going to plug that in for A. So x minus 1. So that's A, and we still have to square it. Plus B squared. So B in this particular case is going to be this x minus 2. And we're going to square that one as well. And that's all equal to our C squared. And in this case, that C we said is 5. So that means we're going to do 5 squared. All right, so all we did is we substitute our A, B, and C, and now we got to do the math. Now, we do have a square of a difference for that x minus 1 squared. And you could go ahead and use what you know about squares of a difference, and if you're not sure what that is, if you don't remember doing that, well, you could always rewrite this. X minus 1 squared means x minus 1 times itself. And you could use the distributive property, you could FOIL, you could do a grid or box method, go ahead and multiply these out together. But in the end, when you go ahead and multiply these, this ends up being x squared minus 2x plus 1. So all you're doing is you're foiling. So we end up with x squared minus 2x plus 1. Now we're going to do the same thing with that x minus 2 squared. So again, if you need to, split up that x minus 2 as x minus 2 times itself because it's being squared. And if you do the math here, we end up with x squared minus 4x plus 4. All right, so that's our a squared and our b squared. Now we got to do our c squared. Well, c is 5, and if we square 5, well, that's going to give us 25. Okay, so now what we want to do is we want to combine our like terms. So let's go ahead and combine our like terms here. And the first term that I'm going to combine is going to be these x squareds. So I got a 1x squared. Remember, there's a 1 in front of these. And another 1x squared, giving us a total of 2x squared. Then I'm going to go ahead and combine my x's. So negative 2x and negative 4x. Well, that's going to give me a total of negative 6x. And last but not least, I'm going to go ahead and combine my, my numbers here. 1 and 4. And 1 plus 4 is going to give me 5. Now all of this is still equal to our 25. So I've combined everything on the left. Now, you could solve this in many different ways. We could go ahead and set this equal to 0 and you could try to factor it out. Or you could go ahead and set it equal to 0 and use the quadratic formula. Or you could go ahead and complete the square. Lots of different ways here. What I'm going to do is I'm going to go ahead and complete the square since I did this recently with some of my students. So we're going to go ahead and practice completing the square. So to complete the square, we want that x squared value to be 1. So I've got to get rid of this 2. So I'm going to divide by 2. And to be fair, we got to divide 2 with everyone. So I divide everybody by 2. And when I divide everybody by 2, we're now left with x squared minus 3x plus 5 over 2 is equal to 25 over 2. Now that 5 over 2 is not a perfect square. So what we're going to do is we're going to get rid of that 5 over 2 by subtracting 5 over 2 on both sides. The 5 over 2's on the left will be gone. And that's going to give us x squared minus 3x is now equal to, well, 25 minus 5 is going to give me 20. So we have 20 over 2. And what we want to do is we now want to complete this square. So we're going to go ahead and complete the square by, so now we're going to go ahead and complete the square by doing b over 2 squared here. And our b value in this case is going to be this negative 3. So I'm going to go ahead and take that negative 3 and we're going to go ahead and square it. We'll do negative 3 over 2, and we're going to square it. So that's going to give us 9 over 4. So we're going to add 9 over 4 on both sides. Okay, so now if we add these, we got to have a common denominator. Well, that common denominator is going to be 4. So I got to multiply both of these by 2. So 20 and a 2 by 2. So that's going to go ahead and change this to a 40 over 4. So now I can combine those. So now we're left with x squared minus 3x plus 9 over 4 is equal to 49 over 4. All right, so now we have a perfect square trinomial. That's the whole point of completing the square. So now I want to go ahead and factor out this left side because it's a perfect square trinomial. I could square root the first one, which is x, square root the last one, which is 3 over 2, and we take the sign in the middle, which is a minus sign, and we square it. And that's all equal to 49 over 4 still. Now, to get rid of our square, we'll do the square root on both sides. Now, the square and the square root will cancel each other out, giving us x minus 3 over 2 is now equal to the square root of 49 over 4. And that's going to give us plus or minus 7 over 2, because the square root of 49 is 7, and the square root of 4 is 2. So this is what I want to solve here. I want to go ahead and solve this particular problem, which means I have two possible situations. We have our x minus 3 over 2 is equal to positive 7 over 2. So that's the plus sign. So that's this plus sign over here. And then we have another situation where we have x minus 3 over 2 is equal to negative 7 over 2. And that negative sign came from this minus sign right over here. So here's our two problems here. Now all we got to do is add 3 over 2 on both sides. So we're going to add 3 over 2 over here. And when we add 3 over 2, we end up getting 10 over 2, which is equal to 5. And the second one, we add 3 over 2 on both sides. And that's going to give us x is equal to negative 4 over 2, which is equal to negative 2. Now the question is, well, which one's our actual answer? Now if we take a look at our triangle, we want to plug in our values in for that x minus 1 and that x minus 2 to find out the length of each side. Now, if I go ahead and plug in these values, if I go ahead and write out our answers here, as we said earlier that our possible solutions is x is equal to 5 and x is equal to negative 2. Well, if I plug in that 5, well, that means our a value is going to be 5 minus 1, which is 4, and our b value is going to be x minus 2, so 5 minus 2, which is 3. But if I plugged in that x minus 2, that means our a value will end up being negative 3, because negative 2 minus 1 is negative 3. And if I plug it in for a b value, that means negative 2 minus 2, which is negative 4. And, well, I can't have a negative length. So therefore, our solution is going to be x is equal to 5, and our a value will be 4, and our b value will be 3. Okay, I hope this helped out. And again, you need to be able to figure out whether a triangle is an acute, obtuse, or a right triangle by using the Pythagorean relation. And we should also be able to solve for a missing variable, just like this one over here. If you have any questions, leave a comment. Give me a thumbs up if you like this video. And don't forget to subscribe. All right, good luck, enjoy, and have fun.